Okay, let's take a look at the ANOVA table and how to present and interpret results for an ANOVA. Start with looking at the ANOVA table. To highlight the relationships in the ANOVA table, I'm just going to give partial information here. We'll work through and get things as we go. First of all, note that I have an ANOVA with 3 groups, and I've given you degrees of freedom total and sum of squares total and error. So the first thing I'm going to get is the degrees of freedom for treatment and error, and I'm going to do that by recognizing 2 things. First of all, the degrees of freedom for the treatment is going to equal the number of groups, 3, minus 1. That's going to give us 2, and then I know that the total is broken down into treatment and error. So treatment plus error is going to give us the total. So 3 minus 1 is 2, and 23 minus 2 is 21. So the next thing I'm going to get is the sum of squares for the treatment, and just like degrees of freedom, the sum of squares for treatment and error sum to equal the total. So I can take 184, subtract 126, and get a sum of squares of 58 for the treatment. To get the mean squares, we'll take each sum of squares and divide by its respective degrees of freedom. So 58 divided by 2 and 128 divided by 21. We won't do it for the total yet, because that's usually not presented on this table, but I'll go ahead and note that 184 divided by 23 is the variance for the whole data set. So there we have it. 58 divided by 2 and 126 divided by 21 gives us the mean square for treatment and error. And then we can take that MSTR divided by MSE and get the f-test value. We won't compute the p-value here, but just a note on interpretation. In fact, that's usually the first thing you'll look at when you get to an ANOVA table. You look at the p-value and see if it's low, because if the p-value is low, you'll reject HO, and in this case conclude that there's at least one difference between population means. Okay, now let's take a little closer look at each row of the table, and we'll start with error. We're going to look at SSE, the variation within groups. It's the variation of individual values from their respective group means. So you can see over here, I take within group A the individual values, subtract the mean of that group, square it. So I'm getting sum of squares for that group. Then I'm going to do it for the next group, individual values of B minus the mean of group B, square them and sum them, and then the same thing for group C. And that's going to give us the sum of squares, or 126. The mean square then will be that 126 divided by 21 to give us 6. I've also included at the bottom here a different way of calculating MSE, one that highlights another feature of MSE that I think is worth noting. So the first thing I've done down here is compute the variance of group A. That's just using the normal formulas. Then I did the same thing for B and the same thing for C. So now MSE can be thought of as the average of the 3 variances. S squared A plus S squared B plus S squared C divided by K, where K is the number of groups, in this case 3. Let's look a little bit more at these formulas. The sum of the A sub I minus A bar squared, and the same thing for B and C. Those numerators are what we have up here with SSE. The degrees of freedom that we have, this is N must have been 24 in this case, 8 per group. So 8 minus 1 is 7 in this group, another 7 here, another 7 here. Add those together and you get 21 degrees of freedom for the error term. Okay, now let's look at the sum of squares treatment and mean square treatment. First of all, let's note that the sum of squares treatment is the variation of the group means from the grand mean, or the difference between means if you want to think of it that way. The analog of x bar A minus x bar B when we were just doing the 2-sample t-test. So we take the group mean for group A, subtract the grand mean, x bar bar, square it and sum it. Variation of group means from the grand mean. We'll do the same thing for group B and the same thing for group C. Add all of those up and we'll get the sum of squares treatment, the 58. Then if we take that 58, divide by its degrees of freedom, which is 2, we'll get the mean square treatment of 29. Okay, now we'll look at the sum of squares total, the variation of individual values around the grand mean. So we'll take each individual value x sub I, subtract the grand mean, square them, and sum them. Now this should look familiar. This is just the numerator of the standard deviation or variance that we've been computing all along. It's just that since we're looking at splitting in things to 3 groups, we're going to call this x bar bar here. That's the mean of the whole group. So if we had all 24 numbers in one column, we would just compute this just like we would any other standard deviation or variance. Then we'll take that sum of squares total divided by the degrees of freedom, n minus 1, which is 23. So 184 divided by 23, that's 8. That's just the variance of the entire data set.